In this video, we are going to solve a long exam question. I know some of you may have encountered this question already, and I know most of you know how to solve it, but I want to focus here not only on how to do it, but also how to write it down in an exam to make sure that you're clear enough and you can get full marks. So the first step is going to be for you to stop this video and read the whole question. We have a function p of x that tells us the profit made in euros when x bags are produced by a small factory. The first thing we want to do is to find the coordinates of the y-intercept and the x-intercept of the parabola p of x. So we just have to apply our knowledge of quadratic functions over here. But in general, if we want to find the y-intercept, so we want to find the point 0, p of 0. So we want to know what happens when we substitute the value of x by 0. And we can see here that if x is 0, then the first term x squared, negative x squared, is going to be 0, and then plus 85 times x is also going to be 0, so the only term that survives is the independent term. So the y-intercept is at the point 0, minus 100. For the x-intercepts, we are looking for the values of x that make the value of y to be 0. So we want to solve when p of x is equal to 0. So we are trying to solve minus x squared plus 85x minus 100 is equal to 0. We need to apply the quadratic formula. We can see here that the value of the coefficient of x squared is minus 1. The value of the coefficient of x is 85. And the independent term is minus 100. So we need to find minus 85 plus minus. Then we have 85 squared minus 4 multiplied by 8, which is negative 1, multiplied by c, which is negative 100. Square root of all of these, and then we need to divide all of this by 2 times a, which is 2 times negative 1. So let's simplify this a little bit. Minus 85 plus minus square root 85 squared. We'll find this in the calculator in 1 minute. And then we have negative times negative times negative. So this is going to be negative. And we are multiplying 4 times 1 times 100. So 400. And all of this divided by minus 2. Using the calculator, this is negative 85, and then we have plus minus square root of 6,825 divided by negative 2. Okay, so this will be the exact value of each of the x-intercepts. So the exact value of the x-intercept is minus 85 plus square root 6,825 divided by negative 2, 0. And then we also have negative 85 minus square root of 6,825 divided by negative 2, 0. It's going to be useful to know what are the approximate values of these horrible expressions. So I'll write over here, this is to three significant figures 1.19, and this other number is to three significant figures 83.8. So let me write over here the information we already have for part A. The y-intercept is at the point 0, minus 100. And then there are two x-intercepts at the points, I'll write approximately, because that's what's going to be useful later on, 1.190 and approximately 83.8, 0. So we are ready now to move on to part B. We want to find the equation of the axis of symmetry and the coordinates of the vertex of the parabola. So let me write B here. We want to write axis of symmetry. Well, that's going to be an equation. It's going to be x equals something because this is a vertical line. And actually, you can check in your formula booklet. This is given by minus b over 2a. A is the main coefficient, the coefficient of x square of our quadratic, and b is the coefficient of x. So in this case, this is negative 85 divided by 2 times negative 1. So this is negative 85 divided by negative 2, which is 42.5. So the equation of the axis of symmetry is x equals 42.5. Now we also want to find what are the coordinates of the vertex. The vertex is the point that is at the same time in the axis of symmetry and in our parabola. So it's going to have x coordinate 42.5 because that's the x coordinate of all the points in the axis of symmetry, and the y coordinate is going to be the result of evaluating the function at 42.5. And using the calculator, this is x coordinate 42.5, y coordinate, I wrote it over here, 1706.25. This is an exact value, but we may want to also save the value approximated to 3 significant figures. So 42.5, 1710. That will be the approximation. So let's save this information for later. We got here axis of symmetry with equation x equals 42.5 and vertex coordinates 42.5, 1710. Approximately, this is approximated to 3 significant figures. Let me write here the exact one in case we need it later. It's here said. Now we need a little bit more of space for part C because we need to graph the parabola using, of course, the features that we already found in part A and B. They are giving us the scale. We want 1 centimeter for 10 units in the x-axis, and if you look at the information we have so far for the x-axis, well, the largest point we have is 83.8, so we are going to need roughly 9 centimeters for that, and we don't have any negative value of x, so we're going to need more or less 9 centimeters for the x-axis. And then for the y-axis, they tell us to use 1 centimeter for 250 units. We need to go between minus 100 and 1,700, so that's roughly 1,000, well, let's say it's 2,000, so we need also roughly 8 centimeters. Okay, I'm not using graph paper here, I'm just using paper with squares that we have over here, and that's good enough. And we're just going to say that each of these squares has sides of 1 centimeter. So I'm going to need to have axis, and we need to show the first quadrant and just a little bit of the negative y-axis, and we need at least 8 centimeters on each side. So let me see how we can do this. And I promise this is easier for you because you're just going to do it with old-fashioned paper and ruler, and I promise that works even better. So let's see over here. I know I'm missing a little bit of the x, but we're gonna add it later. So let's say x is there, and then here we have p of x in the y-axis. Let's check that we are doing fine with the scale. This would be 250 euros, then this is 500, 750, 1,000. Let me write here. 1,200, 1,500, 1,750. I don't really need more than that, so maybe even I want too far over here. Sorry, I didn't want to do that. I'm telling you, just paper and ruler is easier. So that will be my y-axis. I just need to add a little bit of negative side here. Yep. Let's say minus 100 is here. And let's see the x-axis. 1 square is going to be 10 units. So this is 10 units. 20, 40, 50, 60, 70, 80. Well, we can go here up to 90 even though we don't need it, and we don't need to go farther than that. So we can erase this. Okay, this is what I need for drawing my picture. So now let's start adding the points we know. We know that the y-intercepts at the point 0, minus 100. We have this point here. And let me write that this is the y-intercept. We also have the x-intercepts. Well, I can't really see very precisely, but let's say the point here is approximately 1,910, and this is one of the x-intercepts. And then we have 83.8 approximately here, 83.80, another x-intercept. We also need the axis of symmetry. I'm going to put a ruler for that. It has to be a vertical line, and I need to find where is 42.5. So 10, 20, 30, 40 should be around here. So that will be my axis of symmetry. X equals 42.5 axis of symmetry. And for our vertex, we need to locate the point approximately 1,710. So 42.5, 1,710. This is my vertex. Approximately. These points are all approximations. The concavity of the parabola is negative, and now we are ready to just sketch it. And here it goes, y equals p of x. And that was what we were requested to do for part C. Our next goal is to use the graph to answer some questions that bring us back to the small bag factory. And that's what we're going to do in the next video.